Good afternoon, everyone. I'm Gauri Krishna. I'm a BTech third year student in CSE at Kalyan University. So today we will see the first experiment in MLT, which is exploratory data analysis and data preprocessing. So today, I'll share the code. So this is the So this is the first experiment in MLT lab, which is exploratory data analysis and data preprocessing. So the aim of this program is to perform the exploratory data analysis and data preprocessing on the given stored data set using Python, and in order to and for data distribution, for detecting the outliers, handle the missing values, remove duplicates, prepare the data for further analysis. So here in the first here we are importing all the libraries for our pandas. So here pandas and NumPy, Matplotlib, Seaborn, and SkyPy. These all are the libraries that I've used. And here I'm reading the dataset, which is stores1a.csv. I've used the dataset stores1a.csv. And the first question, we are displaying the number of rows and columns. So for that, we have used df.shape. It will uh, it will display the rows and columns. And in the question two, so in question two, we are counting the categories and the numerical columns. And for this, df.select the data type, include equal to object string. Uh, so this function selects only the columns in the data frame that have a data type of object. So string, these are the categorical columns, and dot columns, it will definitely attributes get the names of those selected columns, and this result and the stored cat columns. And df dot select the data types include np equal to number and dot columns. This will store the data in the num columns here. And in the third one, we'll find the minimum, maximum, and mean values of the numerical columns. So df num columns, this will select only the numerical columns from the main data frame. df using the list of column names we are created on the previous step. And dot aggregate, it's an aggregate operation over the specified axis. Here we are applying these functions like minimum, maximum, and mean to every selected numerical column. So this result is related in a new data frame showing these statistics for each column, giving a quick overview. And it will print an output like this. And in the question here, will number the summary and the box plot for each. So here it will sms.boxplot, it will print the box plot for each. And in the question 5, it will detect the outliers in the quantity using IQR. IQR means the interquartile terms, and the equation for finding IQR is Q3 minus Q1. Q3 is high and Q1 is basically low. So this will create the IQR value, and based on that, we have plotted the box plot for the value quantity. And here, uh, in the system, we'll detect the outliers in the quantity using the z-score value, and z-score. This function from this SkyPy calculation. It will calculate the z-score for every value in the quantity column, and the z-score tells you how many standard deviations are there in a data point from the mean. And NP here, it will print or it will create the box plot for the quantity, for the value quantity. And then here it is the correlation analysis. Correlation analysis basically tells you like the relation between two data types, like how these two data sets are related each other, and the features we have used the features age, price, tax, quarterly tax, rating. Based on this, it will calculate the correlation and a value close to 1 indicates a strong positive linear relationship, and the value close to -1 indicates a strong negative linear relationship. And if the value is 0, means there is no relation at all. And here the core dot here in this eighth question, we will display the features of pairs with high positive correlation and high negative correlation values. So here the core dot unstack this and towards the correlation matrix, and it takes the 2D table of data into and it makes the tempo 1D table series with a multi-index value, tax and price, and we get the output like this. And here it will filter the high positive correlation, basically correlation which is greater than 0.6. This creates a Boolean mask where true indicates a correlation which is greater than 0.6, and the correlation not equal to 1 means this creates a Boolean mask where true indicates the value is not 1. And we got the output like this. And in this, it will find the student's analysis of tax, sorry. So it will SNS dot his dot, it basically prints a histogram of the tax column, and the KD equal to true means the argument adds a kernel density estimation curve, uh, like we can see here, which is a smoothened line that estimates the probability density of function of the data, and this helps in the visualization of the distribution of this shape. And the plot dot show it displays the plot. So here we got the output, and uh, in this we calculate the univariate analysis for city, and the SNS dot count plot x equal to city means this creates a count plot, which is essentially a bar chart showing the frequency of each unique category in the city column. And on the 12th one, we univariate the analysis of rating, same like above. The SNS dot swan plot rating. A swan plot is it's like a categorical scatter plot, and for a single continuous variable, it places each data point along an axis, and it ensures that don't the keys they don't overlap, and this shows the distribution and all individual data points. And bivariate analysis, it's also a scatter plot, and SNS dot scatter plot is equal to tax. This creates a scatter plot, which is a fundamental tool for the bivariate analysis of two continuous variables. And the bivariate analysis categorical was continuous. The SMS box plot for gender and age. So this creates a box plot that is grouped by a categorical variable. Here the age distribution is shown separately for each category in gender, and the bivariate analysis of two categorical variables, which is PD dot cross tab, uh, PD dot cross tab DF gender and customer. This function creates a cross tabulation table. It shows the frequency distribution of one categorical variable for each category of another categorical variable, and it will print the count plot. And here the multivariate analysis, it's a pair plot. So here we will select the five numerical features and the categorical columns city plot. And the next one is data preprocessing. So for this, I have used the dataset stores 1b.csv. Here also we are importing the libraries and reading the new dataset, which is stores 1b.csv. And Here we are identifying the missing values. So for that, we have used the df.eSnal.sum. eSnal creates a data frame of the shape df, but with true, where a value is missing and it's false otherwise. Dot sum then adds up these true values for each column. It gives the total count of missing values. And then mean imputation for less than 10 percentage of the missing. So this line performs the mean imputation dot the fill now option. It's a panda function that fills the missing values and the argument df age name dot mean. This will calculate the mean of the non-missing value in the age column with the mean of that column. And in this field, it's the nearest neighbor k imputation. So in this from sklearn dot import this KNN imputation, it imports a more sophisticated imputation tool from the scikit-learn library. KNN imputer fills in the missing values using the k nearest neighbor algorithm. And here the imputer equal to KNN imputer. It's an instance of the imputer is created, and it means it will look at the first five most similar rows to find the value. Fill a missing to find the value to fill in a missing entry. And the mode imputation for categorical data. So here the df city.fill now df city.mode. This function returns the most frequent value in the city column as series. And here the df city.fill now, it will similar to mean the imputation. This replaces all missing values in the city column with the mode. And here we are dropping columns with high missing values, and it's like before equal to df dot shape, and it says the original shape, and df dot eSnal dot mean, it calculates the proportion and of the missing values for each column, and df dot eSnal dot mean less than 0.10. It creates a Boolean series. So here we're dropping outlier rows using the set score value. So np dot abs stats set score. This calculates the absolute z score for the quantity column, and it creates a Boolean series, and it is true for rows where the absolute z score is less than or equal to 3. And in the 23rd question, you're finding the percentage, here the percentage of duplicate rows. So df dot duplicated means this function returns a Boolean. So this word true indicates that the previous row is a duplicate. The indicates that row is a duplicate of the previous one, and previous row, the first occurrence of unique row is marked as false. And odd sum means that sum of the true values giving the total count of the duplicate rows. And in this, we are dropping the duplicate rows. So df dot drop duplicates is equal to 2. This function removes all the duplicate rows from the data frame. And this 24th, we'll find the duplicates based on specific columns. So the specific columns are customer, age, gender. A list of specific columns is defined. The df dot duplicated subset equal to calls the subset parameter tells the duplicator to only consider specified columns when checking for duplicates. And here we are dropping the duplicates based on columns. So for this, df dot drop duplicate subset equal to columns, and the int is equal to true means this removes the duplicate rows, but only consider the column listed in the calls to determine if a row is duplicate, and these are the output. And here we'll find the minimum maximum normalization using this subtract the minimum value of the age and age column from each value and this shift the data so the new minimum becomes zero and the df dot age min max this result which is the new series which values is between 0 and 1. It is stored in a new column and called age min max. And this is the here we are performing the Z-score normalization for numerical feature, and we have got a scatter plot. And here we'll perform the label encoding for a categorical feature called fuel type using the Python code here. So we've got payments and payment label, and here we are performing the one hot encoding for a categorical feature, fuel type again, and the payment cash, payment credit card, payment eval. These all are the values we got. Dummies.head, it will print all the first five rows, and we have got the output like this. And here in this, it will the exploratory data analysis help in understanding the data set characteristics, relationship between the features and everything, and to help the and to detect the outliers. And data pre-processing successfully handled the missing values, the duplicate and outliers, normalized numerical features, and encoded the variables. So yeah, this is all about the first experiment. Thank you.